Okay, so here's that problem 813. That's a sketch of it. What happened? And then I called this part number 1 up here, and this was part number 2. That's how I did it. Okay, so the first thing you had to do was find the area of each one, right? And that's given in the book. 42,100. If it makes any difference, I did that while I was doing the problem too. Don't know why.
If we see something like that on the quiz, will we have to look at find it in the book, or will you just give it to us?
You mean for like a part like this?
Yeah.
Well, you'd have to either look in the book or I'd have to give it to you, but I would suspect you could probably look in a book, find that on your own. Yeah. Like in the real world. You know?
Fair enough.
Area 2 is 9,100. I can tell you this, come quiz time, you're going to have to think some on your own. I can tell you that for a fact. Yeah, bless you. Bless you. Okay, now here's where I, in the first attempt, I had a little bit of an error. Now, the Y1 for this, so we're looking for this point right here, right? Okay. According to the book, it says the distance for this 530 by 72 I-beam is 523, right? So it's 523 millimeters, if you will, plus half of this web thickness. The web thickness on that is 19.7, right? According to the book, for this W840 by 329. So that would be 19.7 divided by 2. That's where I screwed up. I forgot to divide by 2. Now, in the overall scheme of things on the numbers on this problem, that really isn't going to make a difference, because we're talking about 10 to the 6th, right, when we get done. So that little minute amount isn't going to make that much difference, but nonetheless, it was a mistake on my part, so I fixed it. Okay? It would be a mistake on your part too, because you're going to show your work, right? In all cases. Okay, so then that turns out to be 532.8 millimeters. Y2. Everybody clear with how we got that? Those values are given in the book, right? The web thickness and such, there's a sketch there, and it shows you all those different values. Okay, then Y2 was simply 523 divided by 2, 261.5, right? The moment of inertia for each piece is given. About the X for 1 is 350 times, or actually, well, that's actually about the Y, isn't it? But that's the Y number, but it is shown as the X in here. 10 to the 6th millimeters to the 4th. IX of 2, 399 times 10 to the 6th millimeters to the 4th. Okay? All right. So far so good. Given in the book. Again, the 840 by 329, that's actually the Y value, isn't it?
Yeah, those are easy to screw up if you're not paying attention.
Yeah. Yeah, because and the first time I did it, it's like, oh man, I had to go back and forth 3 or 4 times to make sure I had the right numbers for that, because it's because it's turned 90 degrees, right?
Yeah, I got screwed up on the L bracket on the last one. I got my X and Y. No one paying attention.
Anything else? But those are given values in the back of the book. You just have to realize that the 840 by 329, that's actually the y value, but because you have to reorient that thing based on the way the picture's shown here. Okay? So then I need the d values. D1 is going to be the 532.8 minus, oh shoot, I can't do that yet, can I? I have to figure out the y bar first. It's going to be 532.8 minus something, okay? But we better figure out y bar first. So y bar equals what? The area of 1. Let's see, let me try to roll that back up a little bit. The area of 1, which is the 42,100, times y1, 532.8, plus the area of 2, 9,100, times y2, which was 261.5, divided by the 42,100 plus 9,100. That turns out to be 484.6 millimeters. So 484.6. D2 is going to be 484.6 minus 261.5. So this is 48.2 millimeters, and this is 223.1. Problem?
We're talking about that orientation problem, the y turns into the x.
Yeah, here, I'll show you here. Maybe this will help. Let's see. You got the Y, the W shapes. It might be a burning question in other people's minds too. So in the book, you're given the W shape like that, right? And that really could be focused a little better, huh? It's on autofocus.
There you go, focus a lot better there.
There, okay. Let's see if that, okay, good. So, you're given these values based on that orientation, right? Okay? So, if you're putting your force in the x direction, your force is pushing down this way when you're talking about the moment of inertia about the x-x axis. If you're talking about the y-y axis, the force, excuse me, is going to be running back and forth left and right along the horizontal axis. Okay? And you're taking your section, if you will, at y-y. Okay? Well, now what happens is this beam is turned 90 degrees, right? So now the y-y is actually on the horizontal. So that's why we go in here then and find IY, moment of inertia, and substitute that value. Because we had to turn this. If we have to turn that I-beam, then we have to use the other corresponding value then for what was the y is now the x, isn't it? Okay? So that's why that has to be like that. Does that help? Sometimes, we have to take that and go like that. That's exactly what we did. We had to turn the table sideways too, didn't we? And you use the YY value now because the YY is oriented along the x-axis now. I guess the only way that wouldn't come into play is if that I-beam, well, actually, on an I-beam, it doesn't matter. It could be if you will, a square numbers, and you still have to change that because of the way the web is oriented. So a piece of square stock would be the only thing that the X and the Y would be the same in some kind of a structural shape like that. Okay? Hopefully that helped. Okay, so now we're down to just figuring out what the moment of inertia is for that, aren't we? So it's going to be the moment of inertia for the x-axis. It's going to be the moment of inertia for the first piece, which we know to be the 350 times 10 to the 6th, plus the area, which we know is 42,100, times the D value, 1, which was 48.2, whoops, 48.2 squared, right? Plus the moment of inertia for the second piece, 399 times 10 to the 6th, plus the area of the second one, 9100, times D2, which was 223.1, and that has to be squared, the D value does. And then we end up with 1.33, or it might be 1.34 times 10 to the 9th millimeters to the 4th. And that's all I ask you to do on this one. Does that help? Where were you going wrong on it?
I had IX, when I did my IX equation, my D1 was wrong. I had 474.75 for my D1.
Yeah, and think about that. That's bigger than the whole system is, isn't it? So you know that value is going to be wrong.
Because I thought E bar was your Y, I thought your D1 was your Y bar minus your Y width, and I used the Y width, the BF number from the table of 19.7.
Yeah, no, it's gonna always have to be Y minus a Y. Yeah. And once again, I would suggest that if you'd have taken a snapshot of that and sent it to me last night, I could have looked at it.
Yeah. Before the class.
Well, if whenever you were doing it, you know, I'm just suggesting that you can always send them to me and I can look at it and see where your mistake is. That would have been a real easy one. Josh?
Where'd you get the 350 from?
The 350 times 10 to the 6 was right back here. And switch. Ooh.
340 by 329, correct?
No, it's a 840. Yeah, 840 by 329.
Yeah,
It comes back up here. Come on. Okay, so that's on page 488 in your book. And there's the 840 by 329. And the IX is the column about in the middle. What in the world?
One's on its side.
Oh, yeah. Okay. I was gonna say, wait a minute. It's the IY. That's the one we have to turn over on the side. This is, yeah, and I went through this.
Then we just talked about
I had to look at my pictures 3 or 4 times to make sure I had the right thing and zoning out. So that's where that number comes from. So we had to flip it 90 degrees and use the Y value for that particular one. Then with, excuse me, if we look at the 530 by 72, then we use the IX, which is in the middle of the paper, the 399. And it's 399, and note up at the top, it's times 10 to the 6th on your chart. You always have to note that, they're going to, what kind of units are we talking, if you will, is what you have to look at there. So, what else? Anything else?
Yeah, I have one question.
Okay.
I have 8.9a. You have applied the formula pi 8 to the power 4 by 64 IO and IO. That's the half circle formula or full circle?
Oh, you were not talking about this problem, right?
No, no.
Okay, okay. So, anything else on this problem? That's what I meant. Jabril?
10 to the power of 6. 10 to the power of 6 for I.
It's on that chart, at the top of the chart. And the way this book does it, they do it on every one of the pages. It's up at the top here. 10 to the 6th. Okay? And now, like on the Z values, see it's times 10 to the 3rd. So you have to pay attention to that. Okay? Now on my calculator, you just type in the 350 and then there's a shift. It's about the second button down. It's shifting the, it's, there's about 2/3 of the way down. There's just a power of sign, and then you just type in the value and it close the parentheses. It's similar to that, but yeah, mine's not quite that fancy. Mine's just a simple calculator. I didn't bring it with me. I got you guys. Then I have to get, which is really good because then if you don't do it right, you find out. So yeah, and it's just like what Jeff's doing. You have to figure that calculator out and bring it with you come Friday, right? For the test. So if you're not doing it now, you better be practicing it. Okay, so Harihar, what was your question now?
8.9a.
8.9?
Yeah, just little bit.
Well, let's get through these problems first. 8.9 we didn't even assign, did we?
Yeah, that was the homework from last time.
Oh, that was last time. Well, let's get through these, and then what did we do on 8.9? Was it a moment of inertia problem too?
Yes. We actually go back to that one of the problems that we did for today.
Was that for the polar moment of inertia?
Yes.
Oh, well then that's actually, if that's going to be one of the problems, then we'll do it. But
824A goes back to 8.9A.
yeah. Okay. So anything on 815?
Oh, sure.
No, I got that one.
815 was easy, really, wasn't it?
No, we were just finding the.
If you were doing the X, if you were doing the Y, it could have been a little bit more interesting, wouldn't it? Okay. 814 or 815, all you had to do is look in the back of the book, and it's 144 inches to the fourth.
Yeah, so
Essentially the
together.
same as 813 essentially set it up the same way. Is what kind of what I'm looking at.
I said 814, 815. It was very similar to 812. Yeah. 813. No, I don't know that you could say 813 and 815 were similar. It's more like 12, which we did in class, I think, didn't we? I was thinking we did 812 in class.
Yeah, we did.
823. 823 is one of those plug and chugs, isn't it?
Well, you're on forward, too.
Polar moment of inertia.
You're on forward.
And it was pi over 32 times the OD minus the ID. Well, each of those raised to the fourth power. Okay, so that was pretty much a simple process there. 824 referred you back to problem 8-9, right? So when we did 824A, if you will,